Hi everyone, in this tutorial I'll be showing you how you can create an elevation map as you can see on your screen. So this is the map we are going to create today, and it will be having a color palette to indicate the variation in elevation, and we will also be adding these elevation values. You can see it here, 1400, 1300 and all, and there will be a legend indicating the elevation level starting from 673 meters to 2149 meters, and there will be a scale, and we will be adding coordinates and north arrow and all. So initially the first step involved in making an elevation map is to import a vector polygon or a shapefile of your study area. And if you are not having a shapefile for your study area, I have already done a previous video in which I elaborately explained how to extract shapefile from the OSM base map, and you can save it in your drive and you can use it. So do check that video. I have provided the link in the description. Then we will download the NASA SRTM digital elevation data. Then we will do some more, we will follow some more steps to create an elevation map like this. So let's begin. Okay, this is my QGIS and I'm going to start a new empty project. So the first thing I'm going to do is that I'm going to add a vector polygon which is already in my drive. So I'll be sharing all these files with you, the polygon and all, so that you can do whatever I'm teaching all by yourself. So first of all, I'm going to add the shapefile which is in GeoJSON format, which is a format just like .shp, .kml and all. So I'm going to drag and drop it here. These files you can download from Google Drive. I have provided the link to download these in the description. So now I'm going to remove the fill color of this shapefile. This is my study area, imagine. So I'm going to do a right click and go into properties. And there is an option called control feature symbology. You just click there. First of all, you have to go to simple fill, then go to fill color, because we are going to remove the fill color by dragging this. Okay, done. If I click apply, the fill color will be removed. And in the next step, I'm going to increase the thickness of this boundary line, which is called stroke width. So let us increase it a little bit, 0.46 now. If I click apply, the boundary line has become thicker. And once I'm done, I'm going to click apply and okay, done. So if you want to get an idea about this study area, what you can do is that you can go to web, quick map services, and go to OSM and add OSM standard base map. Now you will have an idea about your study area, about my study area. So this place is located very close to Munnar, which is a popular tourism spot in Kerala, which is actually situated on the higher elevations of Western Ghats, and there are a lot of hills and all there, grasslands and all. So we are going to create an elevation map for this particular region. And before that, I'm going to increase the transparency of this base map. And if you don't know how to get a base map like this, actually you need to install a plugin first. Then only you will be able to access the base map by going to web, quick map services. So the plugin is going to be, you have to go to plugins, manage and install plugins. And here you have to search quick map services, this one. So if you haven't installed it already, you have to install it by clicking here. I am not going to reinstall it again, but in your case you have to install it, and you can close it once the installation is done. Then if you go to web, this option will be there, quick map services. So if you haven't installed this plugin already, then such an option won't be visible here. You have to install it to access the OSM base map. So the next step is to increase the opacity of this, increase the transparency of this base map. For that, I'm going to right click on the OSM standard base map layer. I'm going to properties, and there is a transparency option, and I'm going to decrease the global opacity. Done. So it looks better now, the base map. And if you zoom in, you will get an idea about the locations, the names, you can see the places. Okay, so what's next? So if I go back to my presentation, you can see the next step is to download the NASA SRTM digital elevation data, this particular step. So where will I get it? So in QGIS, there is another plugin from using which you can easily download the digital elevation data. So for that, this is the plugin SRTM downloader, but if you haven't installed it already, it won't be, this icon won't be visible there. So in order to install it, you have to go to plugins, go to manage and install plugins. And here you have to search SRTM downloader. This one, you just click install and close it. So I'm already ready with this plugin, and I'm going to open the SRTM downloader. Okay, so first of all, you have to click on this set canvas extent. It means that if I click download, what happens is that the algorithm is going to download all the raster tiles of, raster tiles containing digital elevation data for this particular canvas extent. So different raster tiles that are coming or that are falling within this canvas extent will be downloaded. So I have set the canvas extent. This is the canvas. So this is going to be the canvas extent. And if I click download, let's see what's going to happen. Okay, the download has been completed, but this is not what I want, because a lot of times when you are using this SRTM downloader, errors, things like bugs and all appear. So I'm going to close it now. In most cases it happens, like see host URL data donor not found. So I'm going to remove this. This is the raster data, digital elevation raster file the algorithm has downloaded, SRTM has downloaded. So I'm going to remove it, and I'm going to remove this one also. I'll be explaining about this in a while, and let's repeat the process again. So I'm going to open SRTM downloader, and I'm going to set the canvas extent, and let's click download again. So okay, so this is what happens actually. Like in most cases, if you are doing it for the first time, the errors like just appeared, you saw it, right? So such errors will appear again and again. So now in order to download this digital elevation data, you need to have a free account on earthdata.nasa.gov website. So this is the data portal from where you are going to obtain the raster tiles corresponding to digital elevation data. So if you're not having an account, what you can do is that you can click here, this particular link, and you can create a free account here, register for an Earth Data login profile, username, password you have to provide, and some basic informations like the last name, middle name, email, country, affiliation, and all. So this is just a 2 minutes process, and you can complete it quickly. And once you are done, just click register for Earth Data login. You will be provided with a username and password. That particular username and password, the login credentials, you have to provide here. So this is going to be my username, and my password is also here. And once you are done providing these credentials, simply click save credentials and click OK, and click download now. So now let's see what is going to happen, whether the SRTM downloader is going to get the right raster tiles for us, for our region of interest. Let's wait for some time. See, a single tile has been downloaded now. You can see it here, right? But this actually lies outside the study region, but it was within the canvas extent, because this region actually falls within our canvas extent. That's why it got downloaded. Anyways, let's go back. More tiles are getting downloaded. Okay, we have got some more raster tiles. We got another one. We got one here. We got one here. Okay, some error has occurred. I don't know what happened. Anyways, I'm going to close this. download has been completed. See, I don't know why such errors keep on appearing. There has to be some issues or bugs associated with it. Anyways, I'm going to close this now, and if I zoom out, you can see, and I'm going to keep the steady area vector polygon above this. I'm going to keep it as the topmost layer. So now you can see the vector polygon, right? The steady area vector polygon. And the raster tiles, the digital elevation data actually covers my vector polygon. But I don't need this. I don't want all these tiles. I need the digital elevation data only for this particular region, right? So if you check this SRTM images option, you get to see all the raster tiles which has been downloaded by the SRTM downloader plugin. So I'm going to click on this drop down menu so that it's gone. But if you want to expand, you can click here. Okay, that's it. And the SRTM downloader not only download all these raster tiles, but also it combines different raster tiles to form a single large raster layer. As you can see here, this huge raster layer is composed of, as you can see here, multiple raster tiles. 1, 2, 3, 4, 5. Yeah, you can count if you want. Anyways, we'll be focusing only on this particular raster layer. This is going to be the final combined raster layer. The next step you have to do is that I'm going back to my presentation. You have to clip the raster layer using the steady area polygon, which means I'm going to clip the raster layer. I'm going to crop the raster layer using this polygon so that the unwanted portion of the raster will be removed. We'll be cropping this raster along these boundary lines. For that, you can go to raster, go to extraction, clip raster by mask layer. And our input layer is going to be this combined larger raster layer, and our mask layer is going to be steady area. And if I click run and close it, it's been completed. You can see we have successfully clipped the raster layer exclusively for our steady area. And I'm going to unselect this. This is the larger raster layer. I'm going to unselect this here, and I'm going to uncheck the SRTM images, the individual raster tiles. And if I want, I can unselect this OSM standard map as well. See, now it looks better, right? I'm going to keep this steady area polygon above the clipped mask layer. This is the clipped raster layer, and I'm going to rename that clipped mask layer, clipped raster layer, into something else. So this is going to be my DEM layer. Let it be like that. And you can already see the unit, the elevation, the variation in elevation here. So the lowest is going to be 673 meters, and it goes up until 2149 meters. So what is the next step? Let's see. So we need to apply a topographical color palette. So there are plenty of color palettes, but generally for topographical maps, we use this particular color palette containing, blue, kind of yellow, brown, and all. So to find that, you have to right click on this DEM layer and go to properties. And under this symbology option, you can choose single band gray to single band pseudo color. Then there is this color ramp option. You click on this drop down menu, and instead of choosing these color palettes, actually the topographic color palette won't be there. So you have to go to create new color ramp, and from this particular drop down menu, you have to choose catalog CPT city and click OK. So now you will be provided with a set of new color palettes. It's going to take a few seconds. Let's wait. Okay, we have got it now. So here we have got plenty of color palettes now for temperature, bathymetry studies, blues, Discord, etc, etc. But the one we are looking for is here, topography. I'm going to click there, and I'm going to choose this DEM print color palette and click OK. And now you can see different colors have been allotted to different elevation values. So if you scroll down, you can see all those colors and values, corresponding colors, colors and corresponding values. So simply I'm going to click apply and OK. See, that's it, done. So now we have created a topographical map, and the next step is to add contour lines, right? Yeah, we need to extract contour lines and add elevation values. So how to extract the contour lines? It's simple. You have to select this DEM layer and go to raster and go to extraction, and there you will find an option called contour. So we are going to extract the contour lines from this particular raster layer, the DEM layer. And in this dialog box, you have to specify the interval between the contour lines. So I'm going to specify 100 meters. So the minimum distance, I think, between the contour lines will be 100, but it varies based on the topography of the region. Anyways, this is going to be 100, and if you specify a value like 5 meter or 10 meter, the contour lines are going to be congested, and your map won't be looking so good. So that's the reason why I specified a higher value. And the attribute name we are going to use, so we are going to extract the elevation values, right? Based on the elevation, the contour lines will be extracted. So let it be like that and click run. Okay, now we can close it. See, the contour lines have been successfully extracted, and I need to change the color of these lines from yellow to black. So I'm going to right click on these contour lines, and I'm going to properties, and under this control feature symbology option, there you will find this simple line option. Click there, and the color you can change to black if you want. Whichever color you want, you can choose, and if you click apply, you can see the color has been changed. And the stroke width I'm going to reduce a little bit so that the line will become thin. Fine. And I'm going to reduce the color, the transparency of these contour lines. Fine, right? It looks, it looks actually blended with the background colors, topographical color palette. And before clicking up OK, I'm going to add the values, the elevation values. We have to put the elevation values here, right? So for that, you can go to this control feature labeling option, and from this drop down menu, you have to choose single labels. And this value is going to be elevation, right? Because we are going to put elevation values on these contour lines. And if you simply click apply, the values will become visible there. But we need to do some more modifications. So first of all, I'm going to text option, and I'm going to reduce the font size into 8 so that they will become smaller. And you can see here the font is Arial, and if you want, you can change it from this selection. And the opacity of these fonts I don't want to change, but I need to do something else. So first I'm going to choose this buffer, and I'm going to select this draw text buffer, and I'm going to click apply. See, you might have noticed a white colored buffer has been added around these labels so that they will be highlighted. And if I want, I can reduce the strength of this buffer. Okay, fine. But you might have noticed that they're actually above these values are actually above the contour lines. I need to place them right on the contour line. So for that, you have to go to placement and click on the line and unselect this above the line and click apply and OK. See, now we have placed the values actually on the exactly on top of the contour lines. That's it. So I'm zooming in a little bit. Okay, so now we need to create a map, and for that we need to add coordinates, grid cells, etc, and all. And let's begin our second stage. And for that, you have to go to new print layout And before that, I would like to remind you of one thing. This SRTM plugin, this is going to give you so much, so many errors and bugs, but eventually it works. So you have to be patient. You might have to try, multiple times, 2 or 3 times, until you get the digital elevation data for your region of interest. You can, keep on trying with this SRTM downloader. And I don't know whether it's happening only for me. So that's how it works in my case, at least. So to create map, I'm going to click new print layout and simply click OK. And I'm going to select this add map option, and I'm going to click on a top corner and draw it here. See, this has become visible here. So whatever you keep here will become visible in this second print layout canvas when you use this add map option to draw your map. So I'm going to zoom in this a little bit, and if I remove this by clicking and pressing delete, and if I draw this map again, it will be zoomed in, because we have zoomed it in this particular canvas. Okay, next, before adding grid scales and all, I'm going to add the legend. We need to tell the reader that what does this color indicate. Like the green area actually indicates lower elevations. As you go to the higher altitudes, we'll be using different shades of brown to indicate the elevation values. So to add the color gradient legend, you can click here, add legend option, and draw a box here somewhere, wherever you want. So this band 1 gray is going to be our legend. We don't need any of these remaining legends. So in order to remove these unwanted legends, you can select this legend item, and you have to uncheck this auto update box and click on the first unwanted legend and remove, and click on the second one and remove, and click on the third one, remove. You have to do it for the all unwanted legends. So now we are left with only a single legend. This is what we want, right? And it's actually very small. We need to increase its size. So for that, I'm scrolling down a little bit, and I'm going to symbol. And here you can control the symbol width and symbol height. So I'm going to increase the symbol width a little bit, and I'm going to increase the symbol height, a lot actually. It should be, long enough for the readers to understand. Okay, I think it's fine. And you might be wondering why it looks so blurred, this map. If I zoom in, it's not that blurred. It looks perfectly normal. And I don't know why this is happening in QGIS. When you finally create, or when you finally export an image of this map, it looks crystal clear. It is of higher resolution. But when you're composing this map, it appears in very low resolution. I think it's, I don't know what did whether I did something wrong or not. If you know, you just let me know. I can adjust it, or I can correct it. So done. I'm going to place it here, and we need to change the labels, right? So DEM layer band 1, I don't need that. I'm going to change it by double clicking on this DEM layer, and I'm going to put the name of my study area. So I'm putting Munnar elevation. Okay, that's it. I'm going back, and I'm going to click on this band 1 gray, and the unit of our elevation is in meters, right? So I just put M, and I'm going back to the legend item properties again. That's it. It looks fine, right? So if you want to increase the font size of these labels, you can go to fonts and text formatting, and if you scroll down, you will find an option called item labels. So here you can increase the font size of these meter values and all. And if you scroll up, there will be something called subgroup heading. So let me see if I can increase the Munnar elevation. This font size will become bigger if I increase the subgroup headings. Anyways, you can spend some time improving the aesthetics. So I'm going to do one more thing. I'm going to call back this OSM standard, the base map. And if I click this refresh button, the base map will actually appear here as well. So that our map will be having a, kind of good background. See, it has appeared here. Anyways, that's not necessary. Like I like adding, a base map of a base map with a low opacity. So what's next? We have to add coordinates and scale bar and all. So for adding scale bar, you can choose this option, add a scale bar, and draw a scale bar here. Click and drag. And the style of my scale bar is going to be line ticks up. See, this is it. So let's keep it here. And you might have noticed that this legend box is having a background, a white colored background. I don't want it. I want to remove it, or at least I need to reduce the opacity of this background. So I'm going to select that legend item. And if you scroll down, you can see a background option. So if I unselect, the background will be gone. If I select, the background will be visible. So you can change the color here. See. All right. Okay, so in the final step, we'll be adding coordinates and grid cells. For that, you have to click on this map option, and the CRS is going to be EPSG 4326. This is going to be the default CRS in QGIS. And if I scroll down further, there will be an option to add grids. So I'm going to add a new grid by clicking here, and I'm going to select this grid 1 option, and I'm going to click modify grid. So here again you have to choose a CRS. So in QGIS, the default one is, I have already told, EPSG 4326 WGS 84. So the X and Y values are going to be the longitude and the latitude values. So if I put 0.1, 0.1, it means that the distance between this line to this line is going to be 0.1 degrees. So in this particular coordinate reference system, EPSG 4326, the map unit will be in degrees. They won't be in meters. We are actually specifying everything in degrees. So now I'm going to specify 0.09 here and 0.09 here. Fine. And next what I'm going to do is that I'm going to change the line style. Let's make it we want to blend the lines with the background and the map, so I'm reducing its opacity. Okay, done. Where is it? Okay, we are going to grids again. Grid 1, modify grids. Okay, we are successfully added grid lines as well, and there's an option to add frame if you scroll further down. So presently it's no frame. I'm going to create interior ticks. So as I specified interior ticks, you can see some ticks have been added here. So these are going to be the places where the coordinates are going to appear. So I'm scrolling further down. I'm going to draw the coordinates. See, the coordinates have appeared here, everywhere, but they are actually outside this box. I need to pull them inside. And before that, you can choose the format of your coordinates, which is in decimal. In fact, I'm going to choose decimal with suffix. If you want degree minute format, you can choose that as well. Anyways, let it be in decimal with suffix format. And I'm going to bring them in from the left. It's actually, the coordinates are outside the canvas, so let's call it inside the frame. From the right also, let's bring it inside the frame from the top and from the bottom. And if you want, you can control the font color and all here of your coordinates values. Anyways, that's it. So now we have successfully created an elevation map for Munnar region, which is my study area. In your case, you'll be having a different study area. You'll be having a different polygon and all. So this is how you create an elevation map with contour lines and the values. You can see it here. See, they are loading now. Yeah, done. Okay, so finally we will be exporting this map into an image JPG format. So I'm going to click here and let's save it into my desktop. I'm going to put it a name, Munnar elevation map. Okay, click save, and here you have to specify the resolution. I want a very high resolution of 400 dpi, and the file will be opened after exporting. Let's see what we have prepared. See, that's it. And this is of actually very high resolution. It doesn't appear like how it looked in the print compose here in this canvas. Here it looks blurred, but here it looks, perfect. So that's it. Thank you everyone, and I'll be back with another short tutorial soon. Thank you.